Welcome back to this explainer. You now have the neuroscience and you have the policy and disparity material from our first two classes. So, let's talk about it. The brain disease model of addiction, yay or nay? We're tackling one of the most fascinating and fiercely debated topics in modern science and public health today. It's a question that literally shapes everything from how we treat individuals to how governments write laws. I am so excited to guide you through this, so let's jump right in.
Here's our roadmap for the explainer. 1. The brain disease model. 2. Neuroscience of the addicted brain. 3. The pushback, promoting social injustice. 4. Stigma, recovery, and epistemic harm. 5. Health equity and disparities. And 6. Redefining the addiction model.
Starting right off with Section 1, the brain disease model.
Okay, let's dive into this. Is addiction a brain disease? It sounds like a completely settled scientific fact, right? But how you answer this single question totally changes our entire approach to the problem. This foundational concept currently dictates billions of dollars in research funding, and it shapes treatment paradigms all over the globe. So we're going to take a micro to macro journey today to look at the biology and the social justice critiques to finally answer that big question, yay or nay.
To make sure we're all on the exact same page, we need a shared vocabulary. Enter the brain disease model of addiction, or the BDMA for short. This is heavily championed by the National Institute on Drug Abuse in the US, and it firmly attributes addiction to neurocognitive impairments. Basically, it argues that addiction is a chronic, relapsing disorder driven by physical changes in the brain that cause automatic, habitual, and just completely uncontrollable drug-seeking behavior. So what exactly are those physical changes?
That brings us to Section 2, Neuroscience of the Addicted Brain.
Decades of research have synthesized these changes into something called the triadic neural model of addiction. It's essentially three interacting systems. First up is the impulsive system, located in the amygdala striatal region. This relies on dopamine circuits to drive those automatic habits and motivation. Then you have the reflective system in the prefrontal cortex. In a healthy brain, this is what helps you regulate your emotions and think about long-term consequences. But in an addicted brain, it becomes hypoactive. It basically goes offline and fails to inhibit those impulses. Finally, the interoceptive system in the insular cortex takes physical, somatic signals from your body and translates them into what you subjectively feel as an intense craving. When these three systems fall out of balance, recreational use shifts into a compulsive habit.
And this shift is deeply profound. In the neuroscience of addiction, there is a massive difference between liking something and wanting it. Early drug use might activate the opioid system, giving you a sense of euphoria, the liking. But prolonged use disrupts the dopaminergic system, which leads to incentive sensitization. Basically, the brain's reward system gets hypersensitized to the drug and any cues related to it. This creates this incredibly powerful, dopamine-driven wanting or urge to use, even when the person isn't actually enjoying the experience anymore. It's a literal physiological hijacking of the brain's survival mechanisms.
All right, Section 3, the pushback, promoting social injustice.
Now, what's really interesting about this is that as compelling as that microscopic view is, it isn't the whole picture. We have a direct clash here between two prominent scientific perspectives. On one side, researchers like Dr. Carl Hart argue there is virtually no evidence that addiction is a brain disease in the exact same way that Huntington's or Parkinson's are. He says these neuroexaggerations promote social injustice, ignore vital socioeconomic factors like poverty, and actually drive discriminatory drug policies by only focusing on the individual's brain instead of their environment. But on the flip side, researchers like Gillian Beatty defend the model. They point out that neurobiological differences in substance use disorders are very real, observable facts on brain scans, and crucially, they argue that acknowledging it as a biological brain disease doesn't mean we just ignore the psychosocial factors. To them, the social is biological. Things like stress and poverty are physically written on the brain, so these two views don't have to be mutually exclusive at all.
To anchor this abstract debate in some recent history, Hart points back to the 1980s. He notes that the heavily exaggerated narrative that crack cocaine hooked users after only one single hit was actually bolstered by experts with neuroscience leanings. And that specific narrative was then used to justify federal sentencing guidelines that severely and disproportionately penalized crack cocaine over powder cocaine. So for critics of the brain disease model, this is a prime example of how reducing addiction down to just a biological brain deficit can historically drive policies that aggressively punish marginalized communities instead of helping them.
Which leads us to Section 4, Stigma, Recovery, and Epistemic Harm.
We need to look at the individual level to see how this brain disease label actually impacts the person sitting in a recovery group. You'd probably think that calling it a disease removes the blame and stigma, right? Well, recent studies suggest a much more complicated reality. When patients are taught NIDA's model of inescapable biological impairment, critics argue it can cause what they call epistemic harm. By telling someone their brain is permanently broken, you might inadvertently lower their psychological recovery capital and their self-efficacy, their fundamental belief that they even have the power to change. In fact, some treatment-engaged drug users actually report that discussing the brain disease model harms their relationship with their therapist and makes them feel fatalistic. Because of this, some practitioners are pushing for a capability-based narrative that focuses on social empowerment and structural changes rather than purely biological deficits.
Moving into Section 5, Health Equity and Disparities.
If we are really going to understand addiction fully, we absolutely have to examine the macro-level social determinants of health. Think about this number, 17%. According to U.S. national data, the past year's substance use prevalence is nearly identical between Black adults at 17.2% and white adults at 17.0%. So, based purely on biology and behavior, the rates are essentially exactly the same. But the outcomes? They couldn't be more different.
So the crucial point here is that despite having equal rates of use, marginalized groups face drastically worse consequences. Black adults experience much higher rates of criminal justice involvement related to substances. Furthermore, they are less likely to access evidence-based treatment, less likely to complete it, and significantly less likely to be prescribed life-saving medications for opioid use disorder, like buprenorphine. These stark disparities clearly demonstrate that if we focus solely on the brain, we completely ignore the critical systemic issues of health equity, insurance barriers, and systemic racism that actually dictate who survives an addiction.
Finally, Section 6, Redefining the Addiction Model.
So where does this leave us? We need a framework that can somehow hold both the microscopic truth of dopamine receptors and the macroscopic reality of social inequality. And this brilliantly illustrates that we don't have to choose between biology and sociology. The developmental model of addiction integrates both. It shows how an individual's genetic makeup and neurobiology, those dopamine and executive functioning systems we talked about, interact constantly with their psychological attachment experiences and their broader sociocultural context. It acknowledges that yes, a hyperactive reward system is very real, but also that trauma, social cues, and a lack of community resources reinforce the addictive behavior. It shows us that the answer to our original yay or nay question just isn't a simple binary.
Which leaves us with this final, incredibly provocative thought to ponder. Does labeling addiction exclusively as a brain disease ultimately help or harm the person suffering from it? As we've seen, the science is undeniably revealing incredible insights about our neural pathways. But how we frame that science has literal life or death stakes for public policy, for health equity, and for a patient's own belief in their recovery. It's a complex web of biology and society, and untangling it is one of the great challenges of our time. Thank you so much for joining me on this explainer, and definitely keep asking those big questions.